Hi, and welcome back to another episode in the series Getting Funky with Flow, a result type for C# developers. In the last episode, we explored how to use Flow across the wire using JSON serialization, where we attempted to retrieve a supplier view from the backend database. If the supplier ID was found, we received the expected view wrapped in a successful flow. If the supplier wasn't found, we got back a failed flow, indicating exactly what went wrong, clean, clear and without exceptions. In today's episode, we'll follow the same path, but instead of using HTTP client and JSON, we'll be working with a code-first gRPC client and service. On the right, in Solution Explorer, within the Contracts project, I've added an interface called gRPC suppliers service and a supplier messages file to hold the messages used by the gRPC service. Then in the web server project, I've added the concrete implementation of that gRPC service. On the client side, I've created a class called gRPC suppliers service, which acts as a wrapper around the gRPC service client. You don't have to wrap it like this, but I prefer this approach as it just allows for any abstractions I wish to make. And just like we saw in the previous video where I demonstrated a simple extension method for working with Flow and JSON, we can apply a similar strategy when working with gRPC. This gives us a consistent, fluent way to handle network level errors or unexpected server issues and convert them cleanly into flow failures. Let's take a look at the main players in today's episode. I'll skip over anything already covered in the previous video, so if you haven't watched that one yet, I recommend going back and checking it out first. Also, I won't be walking through the server-side configuration. You can find everything you need in the source code, but if anything's unclear or if you get stuck, feel free to drop a question in the comments and I'll do my best to help. Currently on screen is the supplier messages file. It contains two simple record types, one for the request sent to the gRPC service and one for the response returned from that service. gRPC, unlike JSON-based APIs, requires you to define messages, think classes, as opposed to just using simple primitive types. I believe it was version 3 of protobuf.net where support for positional records was introduced, reducing a lot of the ceremony in your gRPC message classes, as shown in the comments below the class. Either approach is totally valid, but if you're new to gRPC, I recommend starting with the attribute-based style. It helps you understand how fields map before moving to the more streamlined syntax once you're familiar with it. Next up is the gRPC suppliers service interface, which might feel a bit like WCF for those who remember it. We define the service contract and the operation contract here. In this case, we expect to receive a supplier's view request and return a flow of supplier view response, all asynchronously, of course. For the query itself, we're reusing the exact same getSupplierView query and its handler from the previous episode. No changes needed there. On screen now is the implementation of the gRPC suppliers service. Just like in the web API version, it uses our instruction dispatcher to route the query to its handler. We've configured AutoFac to scan assemblies and automatically register those handlers based on the interfaces. One important thing to point out here is the use of Flow's returnAs extension method. Our handler returns a flow of supplier view, but the gRPC service method signature states that it returns a flow of supplier view response. ReturnAs allows us to transform the success result from one type to another, in this case wrapping the supplier view inside a supplier's view response. There are other overloads available as well, allowing you to transform failure types if needed. I could have used flow of supplier view for the return signature, but I find a little abstraction helps keep things flexible. On the client side, within the console apps program file, we use the add code first gRPC client extension method. This is similar to how the HTTP client factory works. It registers and configures a gRPC client that uses an HTTP client under the hood. By using this approach, we get a fully configured client without manually creating a gRPC channel and then a service client from that channel. As mentioned in the comments, just like you can add message handlers for HTTP client, you can also add interceptors for gRPC clients, which are effectively the gRPC equivalent. Since we've used the gRPC client factory, any classes that depend on gRPC supplier's service will automatically be provided with a configured service client through dependency injection. Now, I mention this because I personally prefer to wrap the generated client in my own service class, rather than injecting the gRPC client directly into the places where it's needed. I inject it into a wrapper service and then inject that service into my consuming code. It just trades adding a bit of abstraction for flexibility. If you take a look at line 118, you'll see a simple class that expects an gRPC supplier service to be injected via its constructor. Our example service, gRPC supplier service, takes this dependency and can now act as a stable abstraction between the gRPC plumbing and the rest of the application. Let's take a look at the gRPC supplier's service class. On line 13, you'll see that the server-side gRPC service expects a supplier view request, which takes an int in its constructor. But in our getSupplierView method, we just take an int directly. This is one of the advantages of wrapping the generated client. It lets us abstract away the message construction or repetitive setup. That said, you don't have to take this approach. You could inject the client directly if you prefer. Also, just like we did in the previous episode with JSON, I've added a try-catch gRPC result extension. It's used to catch unhandled server-side errors or scenarios where the server is unreachable and convert them into a failed flow. Let's look at how this is implemented. This time we're attaching the extension to a task of flow of T, but the key difference is the type of exception we're expecting to catch. In this case, it's RPC exception. This is the standard single exception type used by gRPC in .NET. It provides a status code and may also include metadata known as trailers. Additionally, it can wrap standard .NET exceptions like operation cancelled exception as init exceptions on the client side. By handling RPC exceptions and converting them into failures, we maintain the same clean flow handling pipeline used throughout the series without littering the code with viral try-catch blocks. Finally, let's take a look at the example code that uses our client-side gRPC supplier service, which contains the configured gRPC service client. The structure is almost identical to the JSON example. We make two requests, one using an invalid supplier ID and another using a valid one. Here's a quick recap of what's happening. We send a supplier ID to the server, this time via gRPC. The server-side service receives the request, wraps the ID in a supplier view query, and has the instruction dispatcher route it to the appropriate handler. The query handler uses a read-only EF core DB context to query a SQLite database using the supplier ID passed in through the query. If a matching supplier is found, a projection creates a supplier view object. This object is then wrapped in a successful flow and returned to the caller. Now here's where things differ slightly from the API controller version. In the API case, we simply returned the result from the handler, a flow of supplier view. But in the case of the gRPC service version, we defined a flow of supplier view response that contains a supplier view for the return signature. To bridge this gap, we use Flow's return as extension method to transform the result from a supplier view to a supplier view response. That's it, we preserve the entire flow, adapt to gRPC's message structure and keep our failure handling clean and consistent. Alright, let's run the app and take a look at the results. As expected, the first request returns a failed flow due to an invalid supplier ID. The second request returns a successful flow containing the expected supplier view. I'll repeat this a few times. You should see the supplier ID value change with each run. Now, just like we did with the previous episode, let's shut everything down and run only the client console without the web server to simulate a connection failure. This will let us see whether our try-catch gRPC result extension behaves correctly when the server is unavailable. As you can see, there's no change in the code, and because we're using Flow, failure is not a showstopper unless we explicitly make it one. So we expect to get 2 failed results here, and sure enough, that's exactly what we can see. Let's double check that the error messages shown on screen are coming from our extension method. Yep, working exactly as intended. One final note, while this series focuses on converting known and anticipated exceptions into failed flows, it's important to recognize that truly unexpected exceptions are a different beast. In some cases, it may be better to let those exceptions bubble up and crash the application entirely, especially if continuing to run could leave the app in a dubious or inconsistent state. Just keep that in mind when handling exceptions with or without Flow. With that, I think it's time to wrap things up for today. As always, feel free to leave good or bad comments and I'll do my best to answer any questions raised. If you found this episode or the source code helpful, please consider liking and subscribing to help support the channel. Anyway, thanks for watching. Until next time, bye for now.